If you start off with a really loose connection, it's got a higher than normal resistance.
Okay, yeah.
As you tighten up the screw, the resistance drops quite rapidly.
Okay, so impact driver. So you're in there, you're super tight, 200 Newton meters of torque. That'll be a better electrical connection, is that right? Now I'm looking forward to this one, hopefully you are as well. And in this video, a continuation of Talk the Talk, we're going to answer the questions that you've posed throughout that series. In order to do that, I've assembled some greats within our industry. I've got Ian from Lewden Palazzoli. I've got a forensic investigator in the form of Rob. We've got Wiha represented by Steve. And back on the channel again, we've got Shahid from the ECA. And I'm going to start off with you, Shahid. Tell me where it says in BS7671, I've got to use a torque screwdriver.
It doesn't.
Oh, good.
There's nowhere in BS7671 that specifically mentions that you've got to use a torque screwdriver. However, in regulation 134.1.1, it says that you've got to use good workmanship, use proper products, and take account of manufacturer's instructions. So when you purchase a product from a manufacturer, could be a circuit breaker, could be whatever,
yeah.
In there there'll be an information leaflet, and on there there's typically stated the torque settings. They may also be stamped on the devices as well. Okay,
well that means to me, I think BS7671 is in cahoots maybe with the manufacturer of those switch gears. So we've got you, Ian, and I love yours because yours clearly sound the earth and neutral bar breakers and the main switch, the torque setting, but why?
They're there to protect the product as well as the conductor and make sure that the electrical connection is suitably tight and doesn't damage the terminal cage, the screw, or crush or break the conductor such that it could cause a failure in the future.
Or you're getting a little bit of a touchback from Wiha, okay, so that completes a circle. You've told me clearly in BS7671 I must use a torque screwdriver. It's there in that regulation, it says you must use a torque screwdriver. You're saying you've got to use a torque screwdriver because we're in cahoots with Wiha, and Wiha, you're chuffed, aren't you? Because we've got to use a torque screwdriver, is that correct?
That's correct, yes.
That's too simple for me, and we're going to investigate this. And talking of investigate, that brings me to you, Rob. You've seen the issues where there has been maybe under-tightened or over-tightened connections. Can you talk me through a typical maybe fire that you've obviously been at and investigating?
Yeah, so quite a common one is a fire occurring around the meter position, but not necessarily involving the meter. There's questions on what has failed, so various people will get involved, representing the different parties, DNOs, meter operators, electricians, household insurers. All those people want to know what happened. And the relevant people will get in, they'll take the evidence away, take lots of photographs, and look at the evidence in a laboratory. And quite often there is evidence of connections being badly made, failing. We call it resistive heating, getting hot in service. And you can attribute that to loose connections. You can often see artifacts of a loose or an over-tightened connection. So both of those can lead to failure.
So we're trying to move the blame, aren't we? So if I'm manufacturing the stuff or trying to sell the screwdrivers, I'm just trying to move the blame from myself to somebody else in that process in order that they're responsible for the insurance claim that's obviously going to come. So back in my day, when I was screwing into the old-fashioned consumer units and maybe using cartridge fuses to protect your RCDs weren't as common as they are now. Why is that torque setting so important now with the type of devices we've got within those consumer units, Ian?
Well, as Rob says, bad connections lead to equipment failure and fire. So as a manufacturer, it's our responsibility to ensure that the product we're producing isn't helping that along its way. We've got to make sure that what we're making is going to be protecting the conductors from under-tightening, from over-tightening, and also protecting the devices from damage, the type of tooling that's used.
Okay, and damage, and we've done that on the channel, haven't we? We've taken a torque screwdriver and we've taken an impact driver to the same device, and we've seen the devastation that would be left behind with the impact driver. But also we're thinking now that we're actually making that electrical connection not just necessary to a piece of wire, whether it be cartridge or rewirable, we're actually connecting it inadvertently or directly to electronic components. And obviously you're worried about those moving and shifting as well and damaging those as part of the products.
Of course. Obviously, as technology moves on within those devices, there are a lot of electronic components, a lot of circuit boards to offer the protection against residual current and now arc faults. And of course, we don't want those terminations to be wrenched and internal damage caused to those components.
Okay, and that's probably going to get more and more, isn't it, as we move through the regulations. We're due a change, depending on when you watch this video, as we go for Amendment 2, and there's a likelihood that more electronic-based protection may or may not come in. Is that correct as we move forward? Then they're talking about maybe having a little bit more of art fault in, which is an expensive device, isn't it, Shahid?
It is a very expensive device. Yeah, so Amendment 2 is not going to be released till the 28th of March of this year. So we can't talk about anything specific in terms of changes. However, there was an indication that AFDDs will increase on certain final circuits within certain installations, and that comes from the press release that was released by the IET at the back end of January.
Yeah, and I think that makes them possibly the torque screwdrivers that are sold by people like Wiha quite a cheap purchase. If you think an AFDD might cost, depending on time, around about £100, that torque screwdriver that's going to maintain the life of that device and make sure you don't damage it, that's where the torque screwdriver comes in, isn't it, Steve?
Yeah, it certainly is, yeah. And I think it's a real important tool to have in your box, especially when you're working on consumer units. And yeah, I think it's the safest way forward for me.
And again, for me, it goes back to we take a calibrated MFT tester, we test our electrical circuits and we record those results. Now we said that we've got to make sure from the regulations that we follow manufacturer's instructions. Manufacturer's instructions say they've got a torque setting on. We understand it's a lot more complicated, these devices, and you provide us the equipment to do that. Is there any evidence, Rob, from your forensic investigation, I just like saying it, so I'm going to say it as many times as I can throughout this video, that torque plays a massive part in whether a fire is going to start or not?
Yeah, there's lots of evidence, and we've done tests over the years to demonstrate the effects of poorly made connections. So, as I said earlier, it's not just it's not just under tightening, which is an obvious one, but over tightening can be a problem. So, you're trying to achieve a low contact resistance. Okay. So that dissipates less heat or produces less heat in service as current passes through. A loose connection. When we've done the test, if you start off with a really loose connection, it's got a higher than normal resistance.
Okay, yeah.
As you tighten up the screw, the resistance drops quite rapidly.
Okay, so impact driver. So you're in there, you're super tight, 200 newton meters of torque. That'll be a better electrical connection. Is that right? No, okay.
No, not quite. The resistance drops to a point. So to understand that is worth thinking what's happening at a microscopic level.
Yeah.
So if you're looking at your copper conductor or your terminal tunnel, your cage clamp, whatever, under a microscope, they are very rough surfaces, like a mountain range.
Okay, yeah.
If you think of the peaks of those surfaces. When you push them together lightly, it's only the peaks that are making contact.
So yeah, very little amount, even though copper looks smooth, very little amount of that being connected.
That's right.
So super tight's better.
So the current,
Okay.
The current is only going through a small surface area when you do a loose connection.
Yeah.
As you increase the torque, you're pressing more of these tips, asperities together.
Yes.
So there's more area to carry the current. The resistance drops quite rapidly. So that's related to increase in torque, which is increase in contact pressure. And the resistance reaches a low point. If you carry on crunching up your conductor, tightening your connector, you achieve very little. And we found that the contact resistance, it doesn't decrease much if you continue to wrench up your conductor.
But you've lost the cross-sectional area.
Exactly. You're starting to squeeze the conductor out.
Thinner, isn't it?
Yes, if you carry on, the resistance can actually increase because you're introducing fractures, you're squeezing out material from that connection.
Yeah, it's spreading.
So a high torque will increase resistance. A high torque also affects the longevity, how long that connection will last.
Right.
So what you need under your contact pressure, under your screw terminal, you need the material to be slightly spongy. So
right, so this is we're describing copper as a spongy material. It doesn't look it to us, does it? So you're saying that's a spongy material. So I'm tightening down onto a spongy material copper?
It's spongy between a certain range.
Okay, yeah.
Or aluminium. We're not talking. I'm talking copper here.
Yeah, let's stick with copper. Yeah. Okay.
That's the realm of the DNOs. But yeah, the copper is spongy to a certain amount. It's like squashing a jelly baby.
Right.
I know you like jelly babies.
I do like jelly babies, yes.
If you carry on squashing that jelly baby, it starts to yield. It squeezes out from the connection.
Right.
If you then release, what you'll find then is the contact pressure will release over time. once that happens, because
So it's getting looser over time. Is that what you're saying?
well, in any connection, there's a natural thermal cycling as it gets hot and cold through daily use,
Yes.
passing current, just ambient temperature, and the connection actually changes. It tightens and relaxes throughout the day as that happens, and the material under the connection needs to be able to stay under constant pressure, and by having the sponginess of your copper,
Yes.
it maintains that contact pressure. If you wrench it up too tight, it work hardens, it fractures, and over time that connection actually works loose.
So because it's lost its sponginess, it actually creates a gap then, does it? Is that what you're saying? Because it's pushed so far down, that jelly baby's so flat,
Yes.
effectively.
Not immediately,
No, over time.
over time, and also if you're manipulating those connections,
Right.
there's less sponginess to accommodate that movement, and you're more likely to pull those terminals loose.
Right.
It's
So,
over time.
so the factors there would be current of higher value over longer periods of time can accelerate this problem of an
Yes.
overtighted terminal. And the fact that if you add movement to it, obviously that's not going to be good. And we saw that in our series of videos when I put a meter tail into the top of one of your isolating switches and did it up to the required torque setting and then gave it a good wiggle.
Yep.
I could pull it out then with absolutely no effort, but it wasn't because it wasn't to the required torque setting, it was because I added movement in. Well, this brings me back to some other things we've discussed on the channel when we think about maybe interrupting the mains end when we're adding stuff for EV, we're putting a prolonged load on, maybe for 7 to 10 hours, and obviously conductors are being moved, and obviously maybe the torque settings aren't correct in the first place if people believe their arm is calibrated and we know it isn't calibrated, and we prove that by having 10 people in to do it. Do you see that we could be in a cycle of increasing the number of electrical fires if this continues on as practice, Rob?
Yeah, definitely. There are trends, and
Okay.
we've seen trends when the load increases and is for a longer duration.
Okay.
They're the key things. What happens is it will take time. It might take years for a connection to deteriorate. This can be a loose connection or an over-tightened connection. When it starts to deteriorate, it can generate more heat locally, and that can actually increase the resistance by oxidizing the material and generally degrading the connection. You get this downward spiral. The connection resistance increases, it dissipates more heat, it runs hotter,
Yeah.
it then deteriorates quicker, and it accelerates towards the end of the life of the connection. You'll get the thing glowing red hot and it'll catch fire.
It sounds remarkably like there you're validating the fact that we should be following manufacturers' instructions, and that goes across the board. So, example being supporting cables into consumer units via glands or some sort of clamp. It sounds like you're supporting the fact that you should follow the manufacturer's instruction and do it to required torque settings because of this jelly baby effect, and when we're squashing it down. So, we've got the jelly baby effect on that one, and that validates you with providing a quality screwdriver that can get to the required torque settings of the actual devices as well. So it seems that we've come all the way round. So if you were perhaps had a crystal ball and could solve the problems of these fires maybe at the mains incoming position, what would be your recommendation to reduce those fires?
Well, it's a combination of factors,
Yep.
but having the right torque is a key one.
Okay, so just pause for a moment there. Steve, would you like to just say something in there?
I think
You would like to agree?
it's a really main factor, especially what you're talking about. So it's fully correct to have the right torque measurement in all consumer units. for me.
Shahid?
Can I just ask, are these made to a product standard? Because I couldn't find any information in terms of the product standard that your screwdrivers are made to. The only standard I found was a VDE standard, which was for the actual the insulating properties of it. So
Yeah, all certification for the product is actually in the packaging.
to a product standard.
Yeah, it is made to a product standard.
In terms of the torque aspect of it.
Yeah, it's got plus and minus 6 on each product.
Okay.
And can you just elaborate for us? While we're there, let's
What's
go.
that?
What's plus and minus 6
Yeah.
mean?
So basically, you've got a tolerance on either side, minus or plus, when it's tested and regulated.
Is that 0.6 of a newton either way?
That's correct,
That's what we
yes.
found when we
Yeah,
did
yeah,
the talk,
that's correct.
the review on it and
So
we
as,
tested it.
as long as you're inside that, the tolerance, that's
Yeah.
what it's tested to. You start going outside, that's where the calibration then comes into it.
Okay. So if I use one of your screwdrivers and I tighten it up to the correct torque setting,
Yeah?
but the product still fails, would you cover me as a contractor in terms of the costs regards the product, my labour time, all the rest of it?
Ian,
Wow, big question.
it's a good question, isn't it?
It is a very good
we'd like an
question.
answer.
Because that's the point, isn't it, from our perspective as contractors? Because everybody seems to be putting the blame on us.
Right.
Yet if we do everything to the letter, does that mean that the responsibilities will feed back upstream, so to speak?
As a manufacturer, you know, our first remit is to produce a product that, with an instruction, that can allow a range of conductor sizes to be clamped securely into the terminal, and as Rob says, not under tight and not over tight. And so, you know, we're looking for essentially a sweet spot across that range. As manufacturers, we have to do a series of tests. I mean, we're bound by standards, obviously, product standards, to get products certified in the first instance as suitable for use.
If I was to do all my terminals up to the required torque setting, I've now moved the margin of error into the product. So if you've got a 1 in a billion, let's make it ridiculous, a 1 in a billion fail rate when they're required at a torque setting, actually there isn't a problem, is it? Because that's within the realms of realism, isn't it, there? So if we do everything we should have, I think the answer probably is you won't get a problem. And that comes back to where Rob was. You should be unemployed because there won't be as many. So out of this, we could find that we're doing you out of a job. He's chuffed a sixpence. Yeah, okay.
Yeah, there'll always be failures, but other mechanisms, not just torque, you know, corrosion or...
And we talked about movement, didn't we?
Yes.
So the point of exiting the meter, we all know this, don't we? The cables come out of that meter, and the DNO or the people who own that meter don't do anything to support their conductors, do they? So they sent the problem to us, didn't they? So we ended up having to put a gland or a clamp at our end, especially when smart meters were coming in. If you were in an ideal world, Rob, would you add a support at that point to obviously start the reducing the problems that are going to be coming down the circuit?
Yeah. Well, I think that's a good idea. Yes. Yeah. So I've seen fires in metering equipment, and there's been an argument as to whether the meter installer installed that correctly, or was it the fact that some guys turned up and put in an EV charge point and some Henley blocks a few days before the fire. You know, so there's always this question, and one party will argue against the other, and it's often settled by solicitors or out of court.
Yeah.
But yes, you've proved with your own tests that you can torque a connection up. You can then manipulate the conductors around and check the torque afterwards. It's not the same.
Absolutely not.
So and the torque should always be checked as the last thing before you leave site.
Yeah, absolutely. And we can see there that by maybe passing the blame back, by not doing the things that maybe some electrical contractors are doing, so by not touching the tails, by maybe only going from the double pole switch and working responsibly, following manufacturer's instructions and doing everything correctly, you'll actually see and be able to maybe easily pinpoint the problem, because the problem would be on the people who installed the meter if there's been no, obviously, touching or contamination of their stuff. But the problem being is that's not happening out there, is it? Everybody's having a dibble and a dive in there. We're adding more load to our circuits in this electrically hungry world. This problem's going to start escalating, isn't it?
It is. And as you said earlier, it's the prolonged loads. So we used to see it a lot when storage heaters would come on. After not being used all summer.
Yeah.
Suddenly there's a long overnight load that's come on to a property, and that will be the time when a lot of fires are seen. In a similar way, you've got electric vehicles, you'll have heat pumps. These are all going to expose the terminals to a longer duration current, which allows the temperature to rise higher than perhaps it would have done previously. If those connections are not ideal.
So you'd probably argue on behalf of maybe Steve, I might put words in your mouth here, Rob, you'd like to see things to the required torque setting. In your experience, you've said to me off camera that you've forensically looked at screws and you can clearly see screws that are loose, that are raised up above the rest of them, and that's where the problem started.
Yes.
Yeah, so if we were to have all of the screws at the required torque setting, actually what Shahid said is we're moving the problem backwards, and then we're trusting our manufacturer. And that's one thing we probably don't do, and we talked about that in the RCD testing, didn't we? Trust the manufacturer that they've produced a product that meets the standards and can disconnect when it was the RCD. Well, let's trust them now that they've produced something that if we follow their instructions and we use the correct equipment, that actually Rob will be at work, which we said earlier on. So you've got, I'd start looking for something else, Rob. You're really good on camera, so maybe do a bit with us. So then it comes full circle, doesn't it? So where we started off and I said, you're all in cahoots, you are. You are all in cahoots. No, I'm going to finish this one.
To the right answer.
Yeah. To get to the right. Yeah, you're right. Yeah, so he's keener now than the first time. You're all in cahoots because you want to follow the manufacturer's instructions. You want us to use the right kit because you want him out of work, is what you really want. So you three weren't trying to get benefit yourself. You were actually going to try and unbenefit Rob from a financial point of view.
This is a ploy.
Yeah, it's a ploy to get him out of work. And what we've seen on social media with the number of fires, especially in that meter box, I can see that problem moving towards the consumer unit again, especially as those EVs come in. Yeah, we're going to be generating more heat in that location, and obviously that's going to be a problem. And over-tightening is as bad as under-tightening, which is a great one. The only way to get it correctly tightened, isn't it, Steve, to use a torque screwdriver?
Exactly.
Absolutely, and follow the manufacturer's instructions.
Can I say from a manufacturer's point of view?
Yes.
A lot of work goes in. Those torque figures are not just plucked out of the air.
Are they not?
They're absolutely not.
Right, okay.
There's a lot of work that goes into. Obviously, there's guidelines within product standards. But there's a lot of work goes in from manufacturers, certainly in terms of terminal design, looking at cage clamp material, the number of blades and serrations that are present on cages, the screw size that's used, the screw head type, the depth of slots, whether it's got an Allen key, the torques that are applied. We're obviously working with a range of conductors here, and we've got to not damage the conductor, we've got to not damage the terminal.
Yeah.
So. As a manufacturer, part of what we do is perform a lot of testing in-house on pull-out forces of cables. So we'll tighten to our torque setting, and we apply weights to ensure that. I mean, they're quite heavy weights as well. If you take a,
It comes back to trust your manufacturer. I trust you've done all this.
Sure.
That's what I'm leaving you to do that. So when I do fit it, I'm happy as long as I've followed your instructions, as long as I've used the correct kit, and therefore I've complied with BSM 671, and obviously we haven't got that issue at the end. But this is what people need to be aware of, isn't it? It's not a master plan. It's actually to conform and save lives. Have you been to instances, Rob, where someone has perished maybe in a fire created by an electrical fault?
Yeah, one or two. Normally the police arrive first in those sort of incidents, and we'll follow up.
And there's your moment, isn't it? As an electrician, do you want to find yourself in court? Do you want to find yourself grievous bodily harm, involuntary manslaughter, whatever it is, when somebody has maybe not survived the electrical installation you've installed? Nobody sets out at home in the morning to go to work to do that and leave it in that position. It's easily solved by following the manufacturer's instructions, and in this case, using the required torque settings on devices. You're passing it back to the manufacturer that you trust and who you have installed in that installation, and probably have done for years, to provide you with kit that won't fail under those circumstances. However, it does lead me nicely into maybe where I want to go next, when we're looking at maybe breakers that are on for 7 to 10 hours and running warm, and maybe they're next to another breaker, maybe the oven, that's on for 2 or 3 hours as we cook that immense Sunday roast. Is that going to be the next problem that we're going to need to look at? And maybe we'll do that. Maybe we'll have Shahid back as well in order to investigate that. I don't think Ian's coming back in a hurry, but maybe at the end he is now. Rob won't have a job. Okay. Hopefully you've enjoyed this series that we've done on torque. We've got a separate CPD that we recommend you go and do to increase your knowledge on it. If you've got to the end of this video, I'd like to think that you're now fully informed and fully aware of how to leave that installation in the safest possible manner. But as always, we're interested in your feedback, your comments, and we will answer as many as we can as well. If you leave them below, I'll try and get back to as many as I can, and no doubt I'll have to ring Shahid on 1 or 2 of those as well to get the technical answer. Thank you.